Hi friends, this is your Python partner here. So today we are going to discuss one of the interesting concepts from Python, and that is function closures. What if I tell you that a function can remember things even after its job is done? Like a cook who walks out of the kitchen but still carries the recipe in their mind. Sounds strange, right? That's exactly what Python's function closures can do. In Python, a closure happens when a function is defined inside another function, and that inner function remembers the variable from the outer function, even after the outer function is done execution. Okay? How to say in a simple scenario? Think of it like this. You go to your friend's house, okay? They give you a backpack with your name on it. And inside the backpack, snacks just for you. But not just snacks. You can add or remove things while you are inside that house. Okay, now even after you leave the building, you still carry that backpack with all the stuff you packed in it. You can open it anytime to use whatever is inside. And guess what? You, the one carrying the backpack, are the inner function. That's how you remember the variables from the outer function, even after it's done execution. Okay, so let's understand this whole concept using this code. So here at first we define a function message that takes parameter x, and this is our outer function. And inside this function we define another one function named greet_of, and that takes y as a parameter. This is our inner nested function. Okay, and here is the real magic happens. Here the inner function is using the variable x, which is not directly from it, but it is using it from the outer scope. Okay, that is from the outer function. So this is where closure happens. The inner function is capturing the variable x from the outer scope, right? Yes. So even after the function message finishes running, this inner function greet still remembers the value of x. Okay. So here our outer function message, it just returns the inner function itself as a function object with a reference to x. Fine? Yes. So this is what is happening inside the function definition. Now in this line, we are just calling this outer function message by passing the argument hi. So now what happens? Yes, this outer function, it takes the parameter x, right? Now the x value is hi. And then this function message defines function greet and it returns it. So now this fun is equal to greet, okay? But this greet has remembered that value of x, that is hi, okay? So now in this line, if you are going to call that greet via this fun, with y value is equal to Radhika. Internally what happens? So our output will be hi plus space plus Radhika. So this is it. See the output? So now this fun has already become a function factory. Now if you want it to act in a different way, like greeting different persons, you can just do it by passing in different names. Now see, let us pass to other names like Ram and Krish and see the output. Yes, hi Radhika, hi Ram, hi Krish. So function closures are useful when it comes to encapsulation. Like in general encapsulation, what is happening? It means we are hiding some details from the outside world and only exposing what is necessary, right? So likewise, when it comes to function closures here, the inner function has the access to the variables from the outer function, but which is completely hidden from the outside world. So, and as well, if we are going to create a function factory that has to generate different behaviors at different times, yes, this comes to handy. Friends, let's quickly see some 2 to 3 questions based on this function closure so it can just help you with more understanding of this concept. Okay, so all the questions will be like what will be the output type. Okay, so try to predict the output. So this is your first question. Yes, carefully see the question and answer. Okay, sometimes you can just make some careless mistakes as well. And this is your second question. It has 2 function factories, it seems. Yeah, predict the output, what would be that? And this is your third puzzle. So what will be the output for this? Yes. So friends, I hope you are ready with your solutions. So let's discuss the solutions. Right. So in the first question, what we have is we have an outer function that has a variable x, which has value 5, and then it defines an inner function. Yes, that is the place where closure is happening, that is the x value is being used, and this outer function is returning that inner function itself as a function object with reference to x. Okay. So in the next line, yes, result is equal to outer of. We are just calling that outer function. And then we are printing what? Type of result. So now what is this result? Result is now a function that remembers x is equal to 5 but hasn't run yet. Got it? So what is the output? Class function. Okay, so I hope all got it correct. So let's move to our second question. So here what is happening is in the outer function, what does it? Make multiplier, and it has that parameter n. Inside that, an inner function that is multiplier that takes parameter x. And yes, this is the place the closure is happening, where the inner function is using the variable n from the outer function, and this outer function is returning this inner function multiplier as a function object with reference to n, right? Yes. So this is with the function definition. So in this question, we got two function factories, I suppose. See, so double is equal to, first we are making that function call to that outer function by passing the argument 2 as an n value, right? Yes. So now what happens? Yes, after getting into all that processes, as we first discussed, double is equal to multiplier with that reference to n value as 2. Okay. Likewise, triple is equal to, we are calling in the outer function by passing the n value as 3. So now what happens? It gets into that function definitions and all those process happens. And now triple is equal to multiplier with that reference to n value, that is 3. So now when we call double of 5, what happens internally? Yes, multiplier remembers the value 2 for the first case, right? So double. So 5 into 2, what we'll get? Yes, 10. And when we call triple of 5, what happens? Yes, this multiplier, it remembers that n value as 3 for this case. So what happens internally? Yes, 5 into 3, yes, we get 15. So our output is 10 and 15. I hope you got it correct. If not, once again listen to it, okay? You'll get it. So our last question, so what we have here, so in the function definition, our outer function is named counter that got an parameter start. And inside that we got an inner function named next count of, it has no parameters in this case. And inside that a closure is happening because it is using that variable start from the outer function. And what happens? This outer function is returning that inner function named next count of as a function object with a reference to that start variable. Okay. So this is with the function definition. And here in this line, yes, we are calling that outer function using that argument 5. So now the start value is equal to 5. So after getting into all that process, now what happens? Count from 5 is equal to next count with a reference to that start variable that is set to 5. Okay, so what will be our output? Yes, start plus 1, 5 plus 1, it is 6. So that's it. I hope you got all the questions correct. If not, just listen to it. And if you got any doubt regarding this thing, do ask me and I'll try to clear it as soon as possible. So friends, that's it for today. So I hope you really enjoyed learning function closures. So friends, practice more and write more programs by including function closures inside it so that you'll get so used to with this concepts. And as well, don't forget to like and share this video. And the most important thing is, yes, join me in this journey of learning. Let's make this journey more interesting and a fun-filled one. Bye-bye and take care.